Okay, Assalamualaikum and hi everyone. So in this video, we are going to learn about the mechanism of nitration of benzene. So this is the reaction that I'm going to use. We have benzene reacted with concentrated nitric acid in the presence of sulfuric acid at temperature between 50 to 55 degrees Celsius. Then we will form nitrobenzene and water as byproduct or side product. Okay, so as you can see in the product, kita ada nitro group substitute the hydrogen yang dekat benzene ni. So maksudnya our electrophile adalah NO2 plus lah. Okay, so we need to form NO2 plus which is our electrophile in the first step. Okay, so how to form electrophile kita adalah we need to break this bond here so that baru kita dapat NO2 plus tu. Okay, but nak break this bond ni kuat, so we need to protonate this hydroxy group first. Protonate means we need to add H plus to this hydroxy group so that the bond here become weaker and then we can break the bond. Okay, but where to get the H plus? This O will go and get H plus from this sulfuric acid. But then they just nak hydrogen je kan, so this bond will break. Okay, so when this bond break, you need to think lah which atom yang akan dapat electron. So let us draw the arrow. Arrow start from nucleophile yang kaya elektron pergi ke H. Okay, and then we just want H. So this bond will break. Okay, so between O and hydrogen, oxygen is more electronegative. That means when this bond break, oxygen will get the electron. So arrow kita dari tengah bond pergi ke oxygen to show that oxygen tu yang dapat electron. Alright, so next we need to draw the product. Okay, so done. Right, so what happened adalah over here, this lone pair is used to form bond with this hydrogen because in a bond ada dua elektron kan. Okay, so kita dapatlah protonated hydroxy group kita. Okay, that means this bond now dah weak. We can easily break it later lah. Okay, but the next product yang kita ada adalah this sulfuric acid here. O yang dapat elektron, so O become negatively charged. Okay. Right, so the next step we need to show bond breaking antara water and NO2 dekat sini. But when this bond break, okay, between O dengan N siapa lebih electronegative? So kena ingat predictable. Dalam predictable, first you will encounter N dulu and then after that O, after that F. So going across a period from NO pergi F, obviously electronegativity increase. That means oxygen punya electronegativity is higher than nitrogen. So that means when this bond break, oxygen will get this electron. Okay, so that's mean over here kita akan form water. Okay, so we can just write H2O over here. Okay, and then another one is NO2. Since NO2 ni tak dapat electron, so NO2 akan jadi charge positive. So NO2 plus. Okay, and then this OSO3H ni sentiasa adalah floating around. But if you want to simplify cara kita tulis pun boleh. Instead of writing OSO3H, you can just write as HSO4 minus, sama juga. Okay, so now kita dah dapat our electrophile which is NO2 plus. Okay, so once kita dah ada electrophile, we can go to step 2. Alright, so next step 2, formation of rhenium ion. So we have our benzene. Ada electrophile kita. So arrow kita dah tahulah benzene adalah kawasan yang kaya elektron. So nucleophile. So arrow start from bond, double bond of benzene ring pergi ke this nitrogen here. Okay, so that means that double bond will break. Okay, and then this NO2 will go to will substitute one of the hydrogen. Okay, and then the other carbon here akan jadi carbocation lah. Okay, and always think about hydrogen. This is skeletal structure, so saya tak draw lah hydrogen. But remember, hydrogen tu sentiasa ada. Okay, right. So this bond here, carbon ni ada 1, 2, 3 bond sahaja. So that's why they charge positive. This carbon ada 1, 2, 3, 4 bond. So dia okay je lah, nice je. Okay, and this is what we call rhenium ion. Dah banyak kali kita jumpa kan. Okay, and then we have to draw the resonance structure for this rhenium ion. Okay, so kita kena memburu positif. So from this double bond pergi ke bonding that is close to positive charge tu. Okay, so now the position ni masih kekal, ni masih kekal, but the double bond ni dah move to here. That means the positive charge dah pindah tempat lah. Okay, and then we need to write another resonance structure, which is this double bond pula yang move to this bond. So kita akan form another resonance structure. Double bond sini, this double bond remain, NO2 dekat sini. So that means the positive is here. Okay, so ini adalah rhenium ion punya resonance structure. Okay, so basically settle for step 2. Okay, so next step 3, deprotonation. Okay, so we know that the reason why we need to deprotonate so that we can form double bond balik dekat sini because benzene lebih stable daripada dalam keadaan dia sekarang macam ni. Okay, so H yang kita nak deprotonate, ini dah kali ketiga saya mention. Okay, hydrogen yang attached to carbon, yang ada benda yang baru kita substitute tadi, not this hydrogen here. Okay, so siapa yang nak deprotonate dekat sini? This H. Okay, this HSO4 minus that you obtain daripada H2SO4 kita tadi. Okay, ini ataupun you can choose to write this one pun boleh, tak ada masalah. So that we can form back H2SO4 kita sebab dia macam catalyst juga. So we need to regenerate the H2SO4. Okay. Alright, so next arrow kita dari mana? Okay, so kalau kamu rasa uncomfortable to use this one, you can use yang tadilah OSO3 H2, the negative is here. So kita start this one, pergi ambil this hydrogen here. Okay, but we just want this hydrogen, okay, not the entire structure here. So we need to break the bond here. So when this bond break, okay, this electron is used to form a new bond, which is double bond dekat sini lah. Okay, so arrow kita from this bond going to this bond. Okay, so that's mean kita akan form the new double bond sini. Okay, alright, so produk kita adalah benzene ring attached to NO2, and then over here tadi dia dah dapat balik lah, which is HOSO3 H, ataupun kalau kamu tak rajin you can just write as H2SO4. Okay, alright, so done deprotonation. That means settle lah kita punya mechanism for nitration of benzene. So as you can see, step 1 je lain sikit, okay, compared to the other mechanism. Alright, so step 2 basically lebih kurang je. Once you have electrophile reacted with benzene, and then you have to show resonance structure of rhenium ion, and then lastly we need to deprotonate this hydrogen so that we can form back our double bond. Alright, so I think I will stop here. Thank you. Bye.